Right, so hello everyone, I hope you're doing well. Little shirt check, representing Jersey today. So today, continuing from the basics we've done before, we're going to look at to see what happens when this insulin and glucagon regulation goes wrong in diabetes mellitus. Starting us off, there's kind of symptoms we could see. Obviously, diabetes occurs when you have hyperglycemia, and that's where the problems start. So that occurs when you have too much glucose in the blood. And that can cause polyuria, which is excess peeing basically, polydipsia, weight loss, and raised glucose as well. So that's kind of characterized. You can do different tests to check this. We've got this venous glucose at fasting, oral glucose tolerance test at 2 hours, and hemoglobin A1C, which we'll talk about later on. And that's kind of like a long-term marker of high glucose concentration. So we start off and we've got our type 1. So this is an autoimmune disorder, meaning that the body basically attacks itself, and the beta cell destruction is usually seen due to apoptosis, and that's initially activated by these T lymphocytes directed against antigens on the cell surface, and therefore the B cells of the pancreas will be destroyed, and this will then cause insulin deficiency. And we see this in quite early individuals, and the treatment is kind of insulin injection. It's kind of the main thing, but also a healthy diet obviously helps as well. And we will also see weight loss and ketoacidosis. Weight loss is quite specific to type 1, whereas ketoacidosis we can see in both cases. And this occurs, so how sensitive your islets of Langerhans are to the destruction is determined due to the mutation on gene 6q. So then type 2, so that's quite later onset, and then that's due to decreased sensitivity to insulin. So what occurs is that your cells can't respond to insulin correctly and can't take in the glucose from the blood into the cells. And this is usually due to obesity and lack of exercise, due to overconsumption. Yeah, the cells kind of get used to this high caloric intake and stop responding. However, it is seen that type 2 is more seen to run in families than type 1. Yeah, it can also be alcohol excess as well, and the treatment is basically with diet and healthy lifestyle and insulin if need be as well. However, it's seen in a lot of papers that you can easily reverse this type 2 diabetes with diet and yeah, a healthy lifestyle. So we've got these two others. So we've got this late autoimmune diabetes of adulthood. So that's basically type 1, but it occurs in adults instead of the young, and it presents like type 2. And then we have this other, which is kind of the opposite, MODY, which is maturity onset diabetes of the young. So that basically is type 2, but occurring in the young, and that's due to genetic mutations, such as the mutation to the enzyme glucokinase, where we talked before, where the glucose then can't be turned into that glucose 6-phosphate and then further on to glycogen and then stored. And that's become unfortunately more prevalent these days, as we see kids are more obese overall. And I think in America it's said that the generation right now may be the first one to live less than their parents, and that's due to that overconsumption of calories. So glycation, so we talked about that before, but let's go into a bit more detail. So glycation is this non-enzymatic addition of glucose to proteins, which alters their function and structure, and this leads to these advanced glycation end products. So basically what happens, and as an example of this here, glucose can be turned into the Schiff base as glucose concentration increases. And this happens normally in the body, it's all reversible. However, if there's too much glucose, the Schiff base can be turned into this hemoglobin A1C, which is a non-reversible reaction. And this gives us a long-term marker of glucose, because the more glucose you have, the more of this hemoglobin A1C will be made, and that can be measured over after 2 or 3 months to see how much of that's developed, and it gives us a better long-term marker of glycation. So what happens when things go wrong? So you can either have micro or macrovascular problems due to diabetes, and what that basically means is macro is kind of the damage done to the larger blood vessels. So we're just going to go through these here. So firstly, retinopathy. So retinal, so to do with the eyes. So what happens normally is this D-glucose is converted through aldose reductase into L-sorbitol, and that's perfectly normal. And this L-sorbitol is then changed through sorbitol dehydrogenase into the D-fructose, and that's perfectly normal because obviously we do need fructose in the body. However, when there's too much glucose in the blood, the aldose reductase makes too much sorbitol, and that can lead to lens damage. Also, in the same reaction, when sorbitol is made, NADPH is used up, and if there's too much of the reaction going on, NADPH can become depleted and can lead to oxidative damage. You can have two types of this damage done. So we've got non-proliferative, which can cause aneurysm and hemorrhages, or we can have proliferative, which means abnormal blood vessel growth, which can obviously both be harmful to the body. So then if we talk about nerves and neuropathy, so that basically occurs when there's damage to blood vessels in the limbs, as well as nerves, which become unmyelinated. And yeah, so basically if you cut off blood supply to the limbs, this can cause ulcers due to the fact that the body isn't able to heal the wounds made. And some people can even develop peripheral neuropathy, where they aren't even aware that the body is wasting away, and yet you can just lose a toe or something, and you might not even feel it due to this. And you're also more prone to infections due to this microangiopathy, which is the leaking of basically your capillaries become weak and start to leak blood and protein as well. So lastly, nephropathy. So that occurs in the kidneys. So you've got this increased mesangial matrix in the glomerulus, causing a decrease in permeability of molecules and a decrease in filtration rate. This means that waste can build up in the kidneys, which is unable to be removed, and then cause damage to the body. So what can we do to stop this? So we've obviously got drugs to help us out. Metformin and glycation, so that increases insulin sensitivity, and it also reduces weight, so that's useful for that type 2 diabetes. Then we've got this alpha-glucosidase inhibitors, which slow the breakdown of starch digestion, meaning that if we can't break down starch, then that can't be absorbed by enterocytes and then enter the bloodstream. Then we've got this sulfonylureas, which act on the potassium channel in the B cells to improve insulin secretion. And then glucagon-like peptide, so they're incretins, which augment insulin release. So you're trying to stimulate that insulin release, because even if the cells are insensitive, such as in type 2, the more insulin you release, the more of a chance you have of it acting. So we've got this ketoacidosis, as we mentioned in the previous lectures. So this is what happens in the medical emergencies with patients that have diabetes mellitus, and that's this uncontrolled generation of keto acids from oxidative metabolism. So we talked about that pathway controlled by malonyl CoA via that CTP1 enzyme. And the clinical features are dehydration, shock, vomiting, and abdominal pain. So what happens when we have this insulin deficiency? So it's basically, it stops all the things that we've been talking about that makes us healthy. So insulin usually inhibits gluconeogenesis and stimulates glycolysis, and without where the levels of glucose 6-phosphate will increase and therefore cause hyperglycemia, which is true for the other points as well. They will result in hyperglycemia. So as we talked about, those in cells with the GLUT4 transporters, which are insulin sensitive, they can't insulin can't promote the removal of glucose from the blood by stimulating those GLUT4 vesicles to surface, and therefore hyperglycemia. Also, insulin isn't there to stop that protein cascade, that complicated thing that we talked about, phosphorylase, phosphorylating, phosphorylase kinase, and stuff like that, so therefore insulin isn't there to break down that glycogen, another way to increase storage. So yeah, basically the breakdown of glycogen is favored in that cascade, leading again to hyperglycemia. So the metabolic consequences, so increased in the hepatic glucose synthesis through that gluconeogenesis and glycolysis. So we've got glucose utilization tissues, in which is normally activated by insulin that's impaired. Increasing the utilization of amino acids for gluconeogenesis is increased, and therefore leading to muscle wastage. As we know, muscle is made up of these proteins, so that's where the body gets it from to keep us running. And we've got this increased availability of fatty acids for oxidation, as well as glucose. We lose, because one of the symptoms is glycosuria, so excess glucose in urine. With that, some of the electrolytes are lost as they follow osmosis. So if we talk about more about this, the fat, the lack of insulin causes, so it's not there to inhibit lipolysis and promote lipogenesis / esterification. So it's not there to promote the storage of fatty acids and inhibit the breakdown of. This means that hormone-sensitive lipase, so an enzyme, increases triglycerol breakdown or triacylglycerol. And that causes these NEFA, so non-esterified fatty acids, to increase in concentration, which therefore will cause acidity, stimulating more beta oxidation, as we talked about, making that carbon dioxide and ketone bodies. And that acidity increases, leading to diabetic acidosis. So the response here, so because we've got this high acid concentration, one way to get rid of it, and we'll talk about this in further lectures, is to shift this reaction of carbonic anhydrate. So in here, the reaction is shifted so that more hydrogen ions and HCO3- is made into carbonic acid, and that's broken down then into carbon dioxide and water. And because carbon dioxide is naturally acidic, we then just simply breathe that out to attempt to decrease the acidity of our blood, and that can cause hyperventilation in diabetic patients as they try to get rid of that acidity. This can then cause dehydration, this ketoacidosis plus hypoglycemia, due to that decrease in glomerular filtrate rate. And we also got this pre-renal urea, which causes increase in urine and creatine. And we also see microalbuminuria in patients in the urine. So that's a marker of diabetes as well, and kind of shows us an early sign of it. So that's basically it on diabetes. Obviously you can go into much more detail about the different stuff, but I just wanted to give a quick overview of the main points. And yeah, hope you enjoyed, and see you in the next video. Hello, I just wanted to do a little quick note on when you get to the description, there's my affiliate link to check it out. There's some interesting things. So I'm basically just promoting these books that really helped me. So there's Clinical Chemistry, Human Metabolism, and Essentials for Human Nutrition. So if you check out them using my link in the description, that'll be great. And yeah, they really helped me to kind of summarize most of these lectures. So yeah, I think they might help you, and it's really worth purchasing them and have a real life copy with you. So if you're interested, have a look. And I'm also, for this topic of biochemistry, diet and exercise, I'm going to be doing a series of episodes as well, and stuff from my first year at uni. I've got these practice questions, so there's over 2,000 questions across the modules. So if you're interested in that, let me know. And yeah, thank you for watching.